Hi everyone. In our previous two presentation session, we covered the first two machine learning algorithms. The first one was decision trees. So before coming into this particular presentation, we should watch both the previous presentation sessions. That is, the first one was on decision tree, and there was an important problem with respect to decision trees. Later on, we covered regression. So in regression also there are two problems with respect to linear regression and one with respect to non-linear regression. So you can go through the entire presentation. So I will send you the important questions when I give you the assignment. So in this particular presentation, we are going to cover one more machine learning algorithm, which is called as artificial neural networks. So before you understand artificial neural networks, first you need to resemble artificial neural networks with respect to human brain. So you need to consider human brain. So through that you can resemble artificial neural networks. So let us see what actually the explanation would be. Your human brain contains numerous neurons. It contains billions of neurons. So those neurons are connected with each other. So one neuron is connected to next neuron. That neuron is connected to some other neuron. So like that, your human brain contains billions of neurons. Every neuron will be receiving information. It will receive information from other neuron, then it processes that information, then it keeps on passing the information to all neurons. Finally an action will be produced. So how we act, it is because of neurons processing inside our brain. So those neurons will have some information that keeps passing from one neuron to another neuron. That entire processing of information inside neurons will lead to some action. So if I'm speaking, then there is some processing which is happening inside my brain. So there is some information which is passing from one neuron to another neuron. So that is what has been explained here. As you can see, the human brain consists of millions of neurons that can link with one another. Every neuron will receive information, it will pass on to other neuron. Then similarly, once the processing is completed, then you will give some action. So as I am speaking, it is because of neuron processing inside my brain. So just like your brain, your artificial neural network acts. So it is in the similar pattern how brain works, your artificial neural network has been designed. So it will be used for many applications. Your artificial neural networks can be used for many applications. We can use it for classification. Classification means either 0 or 1, yes or no. Regression for continuous data, for clustering, that you will be seeing in the next chapter. What do you mean by clustering? If there are some data points, so all data points which are similar to each other. For example, if I want to group you people like on what sport you like, so people who like cricket will be grouped into one group. People who like badminton can be grouped into one group. So there will be two clusters. So you can use artificial neural networks in all this application. Association. This is also one important machine learning algorithm that you are going to see in the later chapter. What is association? Suppose if I am buying bread inside any supermarket, then I might buy jam. So there is an association between those two products, bread and jam. So in all these applications and also in many real-time applications such as marketing, uh, finance, manufacturing, there also you can make use of this artificial neural network. So when you employ artificial neural networks in your business applications, then it will give you some insight on how to obtain profitability from your business. So these are all the areas in which you can apply your artificial neural networks. As I've already explained, each neuron, there will be plenty of neurons. Each neuron in your artificial neural networks will be called as processing element. So each neuron will be called as processing element. So it is a multi-layered structure. So in your brain also there will be many layers, many neurons. Similarly, here also there will be many layers. So there will be an input layer, there will be a processing layer, and there will be an output layer. So the basic structure of any artificial neural network will contain three layers: input layer, processing layer, and output layer. So what you are going to do is your brain, it keeps on learning from your past experiences. So similarly, when you are designing an artificial neural networks, it won't work accurate enough as soon as you design. So once artificial neural network has been designed, you need to keep training that artificial neural network with many samples. So once you train that artificial neural network with many samples, then you will be getting a better accuracy. That is what has been explained here. So it is just like a black box. So you already know what do you mean by black box. So in software engineering, you can see there is a concept called as black box testing, or we can say functional testing. That means the implementation details, how the processing is actually happening, won't be clear. But what input you are giving, what output you are getting, that will be clear. So similarly, your artificial neural networks will act in a similar manner. It will be just like a black box. So these are the points you need to remember with respect to artificial neural networks. It is similar to a brain. In our brain, there will be billions of neurons. So in our artificial neural networks also, there will be plenty of neurons like layers. Each layer will pass on the information to next layer. So when you give an output, you will be getting the output, but there will be some processing happening. So there are many areas in which you can use your artificial neural networks. So you cannot become, you learn from your past experiences and you take suitable actions. Similarly, if you train your artificial neural networks for with a large number of samples, then you can expect a better accuracy from your artificial neural network. This is how your artificial, this is simple model. Given an input, there will be some processing which will be happening inside this network. Once the processing gets completed, you'll be getting the required output. So that is what with respect to artificial neural networks. So where all we can use our artificial neural networks? So we are going to use artificial neural networks in those areas from which we can benefit, from which we can benefit large in a larger way. Or I can say you should get maximum returns, maximum profit in all those fields. I can use my artificial neural networks. So some of the areas where we can use artificial neural, especially whenever whenever the application is complex enough, so it contains huge amount of data. If an application has huge amount of data, complex data, so in such cases I can make use of artificial neural networks to get results. So the best example can be prediction of stock price, because you never know when a stock price will shoot up and or when a stock price will come down. So predicting a stock price, it will usually be done by human beings. But nowadays, there is a proper technique called as algorithmic investing or trading. That means with the help of algorithms, you are going to do investments or you are going to make a trade. So those algorithms will mainly be written with the help of artificial neural networks. And also it can be used for character recognition. So if someone has written handwritten text, so that handwritten text can be recognized using artificial neural networks. So usually old text and all, it won't be in a proper format. So the quality would be very poor. So in such situations, you can use artificial neural networks to recognize those textual contents. So it can also be used to recognize fingerprints. So especially during fingerprint matching, fake fingerprinting, you can make use of artificial neural networks. So it is very difficult when it comes to fingerprint, because each person will have different patterns with when it comes to fingerprint. Those complicated patterns needs to be processed successfully. That will happen with the help of artificial neural networks. And also it can be used to simple classification problems, such as if you apply for a loan, whether to approve a loan for you or not. So it will take some parameters from your end. So based after analyzing those parameters, it will give the result whether to approve the loan or not to approve the loan. So these are some of the business applications where you can use your artificial neural networks: stock price prediction, character recognition, fingerprint analysis, as well as classification problems. So what is the design principles of artificial neural networks? So basically, your artificial neural networks contains many layers. So there will be one input layer and there will be one output layer. In between those input and output layer, there will be many processing layers. So once you give an input, those input will be passed on to the processing layers. Each layer processing unit, we can call processing unit, each processing unit will process this information and pass on the information to next processing unit. So you can give many number of inputs. I can say many features can be given as input. So each feature will be given a weightage. That means ಈ ಇನ್ಪುಟ್ಗೆ ಜಾಸ್ತಿ ವೇಟೇಜ್ ಇದೆ, ಸೊ ಇದನ್ನ ಜಾಸ್ತಿ ಕನ್ಸಿಡರ್ ಮಾಡಿಕೊಂಡು ಔಟ್ಪುಟ್ ಏನ್ ಬರುತ್ತೆ ಅಂತ ನೋಡಿ ಆ ತರ ವೇಟೇಜ್ ನ ಮೆನ್ಷನ್ ಮಾಡ್ಬೋದು ಫಾರ್ ಎವ್ರಿ ಇನ್ಪುಟ್ ಯು ಆರ್ ಗಿವಿಂಗ್, ಫಾರ್ ಎವ್ರಿ ಫೀಚರ್ ಯು ಆರ್ ಗಿವಿಂಗ್ ಟು ಯುವರ್ ಇನ್ಪುಟ್ ಲೇಯರ್. So once you give those inputs, you should also mention the weightage associated with each input. So after the entire processing gets completed, you will get an output. But if the output is not accurate enough, or I can say if the output is not satisfactory for you, then you can change the weights of those inputs. ಈಗ ನಾನು ಏನೇನು ಫೀಚರ್ಸ್ಗೆ ಏನೋ ವೆಯ್ಟೇಜ್ ಅಂತ ಕೊಟ್ಟಿದೆ, ಈ ಫೀಚರ್ಗೆ ಜಾಸ್ತಿ ವೆಯ್ಟೇಜ್ ಕೊಡಿ, ಈ ಫೀಚರ್ಗೆ ಕಮ್ಮಿ ವೆಯ್ಟೇಜ್ ಕೊಡಿ ಅಂತ. ಸೊ ಆಕ್ಯುರೇಟ್ ರಿಸಲ್ಟ್ಸ್ ಬರಲಿಲ್ಲ ಅಂದ್ರೆ ನಾನು ಆ ಟೈಮಲ್ಲಿ ನಾನು ಇನ್ಪುಟ್ಸ್ಗೆ ಏನು ವೆಯ್ಟೇಜ್ ಕೊಟ್ಟಿದ್ದೆ ಅದನ್ನ ಚೇಂಜ್ ಮಾಡ್ಬೋದು. So once you keep changing the weightage for your input, then you can get a better result. So this is how your artificial neural network works. It is not a one-time design process. You should keep on making many iterations. You should keep on changing the weightage associated with each input. So you should keep on doing this until you are getting a satisfactory result. So let us see how it works. Your neuron is a basic processing unit. So it receives input from your preceding neurons. So it is a non-linear weighted computation. As you can see here, so for each of the weight, there are 4 inputs you are giving here, x1, x2, x3, x4. For each of the input, there is some weightage. So all this weightage will be summarized. How you can do the summation? X1 into W1 plus X2 into W2 plus X3 into W3 plus X4 into W4. So it will give one particular value that will be passed on to a function which will do some calculation for that input value. Finally, you will be getting the output. So if you are not getting the desired output, then you can keep changing the weightage you are giving for all these 4 inputs. So this is a single neuron, but practically there will be plenty of neurons. These neurons will be plenty in number in between input and output layer. So all these neurons will be present in the processing layer. A neural network is a multi-layered model. This is what I just explained here. A simple task may be processed by just one neuron. If you are designing artificial neural networks for a simple task, then you might need only one neuron. But for complex tasks, mainly we'll be using artificial neural networks for complex tasks. There you will be needing multiple layers of processing. You will be needing multiple layers of neurons. So in between your input and output layer, there will be many number of neurons and processing units. That is what has been explained. It is a multi-layered model. So each neuron may assign different, this is what I explained here. There will be different weightages given to each input stream. All those weightages along with the input will be summed. So using a sigmoid function. So you can chain this intermediate, as you can see here, this gives a clear picture. So this is my inputs and this is my output. This is my layers. As I can see here, there is 3 processing layers. There are 6 neurons. So all the neurons will be given, all the inputs will be given to the neurons along with their weightage. The summation happens, then a transfer function. This is called as a transformation function, which will do some calculation on this summation value. Then it will be passed on to the next layer. The output from this layer will be passed on to this particular layer. That is why this is called as a multi-layer artificial neural networks. So here I'm giving only single instance. So in order to get better accuracy, you need to train your artificial neural networks with multiple training examples. So you should keep on training because we can't learn from one past experience. We need many past experience to keep on learning. Similarly, your artificial neural networks cannot become accurate by a single set of input. There should be many different set of inputs then only many different set of training samples, then only your artificial neural networks will give some accurate results. As you can see here, the neural network can be trained by making similar decisions over and over again with many training cases. It will continue to learn by adjusting its internal computation. That means weightage change. Finally, you'll be giving some feedback. So from your previous results, you will give the feedback. Thus, neural networks become better at making a decision as they handle more and more decisions, as they trained with more and more training samples. So there will be some point at which you need to stop your training. So you should keep on training. So if you keep on training like that, then you can achieve the accuracy of a human expert. Mainly, you can use artificial neural networks for automatic car driving. So in Tesla and all, they are using automatic car driving. That is with the help of artificial neural networks. So that automatic car driving won't happen in a single stretch. So there, it will be trial and error method. So once they keep on training, they keep on giving many set of training samples, then your system becomes powerful enough to act like a human being. That is what has been explained here. So what all we covered in this? These are the design principles. The first one is, in a single neuron, there will be inputs and each input will have some weightages. You do the summation, then the transfer function, finally we are getting the output. But for if you are designing ANN for a sample problem, then you can use single layer. But in fact, there will be multi-layer. You cannot use only a single layer. There will be multiple layer of processing. Each layer will have many inputs with different weights. You can keep changing the input. As you can see, this is the multi-layered model. And also you need to train your artificial neural networks with many training examples. Only one training examples won't give you accurate results. So far we covered three topics. The first topic we covered is what is artificial neural networks. So it works similar to a brain. What are all the areas in which you can use artificial neural networks? Later on we covered some of the business applications where all you can use artificial neural network. So now we cover the design principles of artificial neural networks. So the next topic is representation of a artificial neural network. So as I had explained, your artificial neural networks won't be single layer because it is mainly used for complex problems. So it will contain many layer, multi-layered model. It is a multi-layered model. In each of the layer, for example, you can see you are assigning weights for this inputs also. So when you are changing the weights, you can change input weight of this inputs, or you can change the weight of this inputs also. So the change in weightage will happen at multiple layer. It won't be only at the input end. The change in weight will happen here also. The change in weight can happen here also. This change in weight will keep on happening until you get the required accuracy. So that is how your artificial neural networks will become better. So that is what has been explained here. So this is what all that is explained in the previous topic. That is, there will be inputs. Each input will be having weight. You will be doing the summation. So each input will have different weight. Then the weighted sum is given to a transfer function. That is what I will be explained here. So based on the prediction, if the prediction, for example, there are some weight you assign to the input and you are getting the result as per your prediction. If the prediction was right, then the weight would remain same. You won't change the weight. If the prediction is incorrect, then the weightage of those inputs should change. Then you will change the weightage of those inputs. So that is the first point with respect to the second point is transfer function. How your transfer function is work. That is, once the summation gets completed, there is a function called as transfer function. So that transfer function, the calculation part here, the transfer function, how it will work? It will work based on some threshold value. So for example, if the computed value, so once the summation is completed, if the computed value is less than 0.5, then you can say output is 0. So there is some, if it's a classification problem, then I can say the output is 0. So if the threshold value is equal to 0.5, then I can try, then the output value is 1, either yes or no. So there can be different, this is one example for a transfer function. There can be many different transfer function. Based on the result of transfer function, you can say whether the output is yes or no, or it can be any continuous values also. So this is how you can use your transfer function. So your neural networks has many in the input values. Each input value will different set of weights. So those values support and compensate for one until a whole learns to provide the output. As you can see, so once you got the result, this weightage might have been correct, but this weightage is what weightage you are given here might be wrong. So you need to change this weight. So even though this weightage is acting correct, this weightage given is wrong. So you need to change the weightage here to get a correct result. That is what has been mentioned here. So in representation of neural networks, it is all with respect to multi-layered weightage, transfer function, and even though one set of weightage is correct, the other set of weights needs to be changed. That is what has been mentioned here. So how we can architect a neural networks? Your neural networks basically works on these three principles. Feed forward. What do you mean by feed forward? So as we saw in the above diagram, there were multiple processing units. There were multiple layers. There were multiple layers. So each layer, from each layer, you will be passing the output to next layer. So each layer will obtain some input, then you will be passing the output to the next layer. So that's why it is called as feed forward. You are giving the output of the previous layer to the next layer. You are feeding forward. Whatever all the data you are getting from your previous layer, you are passing on to the next layer. That is called as feed forward. And also your artificial neural networks, it's not a single layer network. It is a multi-layer network. Each layer will be called as a perceptron. That is why it is called as a multi-layered perceptron. And the last principle is called as back propagation. What do you mean by back propagation? You won't get the result in one single try. You need to keep on changing the output based on some feedback. You will obtain the feedback from the result, then you will change the result. That is called as back propagation. You are starting again from the first scratch. So that is called back propagation. There will be multiple layers of processing element, and the output of neurons are fed to processing unit in the next layers. And the feedback on the prediction is fed back into the neural network for learning to occur. So if you're not getting accurate result, those feedback will be fed back to your neural network, then it learns. So these are the applications in which you can use your artificial neural networks. As you can see in classification, feed forward networks, these are all the principles you are going to use in all these different applications. So there are some, these are the things you need to remember when you are architecting a neural network. These three principles. Which are those three principles? Feed forward, multi-layered perceptron, and the last one is back propagation. So how to develop an AI? There are, so you know you got a picture with respect to artificial neural network. There is a input layer, there is an output layer. There will be many perceptrons, multi-layered perceptron. Each layer will be given some inputs with weightage. So once you get the output, if needed, you need to change the weightage of those input to get to the accurate result. Based on that information, you can develop an ANN with these 9 steps. What are those 9 steps indicates? The first step is you should collect your training data, test data, and validation data. There will be 3 sets of data. So first data is training data, test data, and validation. Training data is nothing but to train your system to become accurate. Validation data is before testing your system with test data. It is a somewhat supplementary kind of thing. So before actually testing with the test data, I will validate whether it is working correct or not. So that data you are going to use while you are validating is called validation data. Then you need to choose the network architecture. The popular architecture, network architecture is feed forward. It is giving the output of one layer, previous layer to next layer. Then you need to choose the algorithm, that is multi-layer. You need a multi-layer perceptron. Then some network parameters you need to set. So the network parameters can be what is the transfer function you are going to use, what is the sigmoid function for summation, all those things you need to set. Then you are training your data with the training data. Then you are validating the model with validation data. So once you are happy with the results, then you will freeze the weights and parameters, other parameters, that is the transfer function and all those things. Then finally, you will test the train network with test data. If you are getting good accuracy, even with your test data, you will deploy the artificial neural networks in that particular business application. These are all the 9 steps you need to remember whenever you are developing an ANN. So you need to gather test data, train data, validation data. Choose your network architecture, choose your algorithm, set the network parameters, train your artificial neural networks, validate with validation data, test with test data. If you are freeze the weights, test with test data. If you are satisfactory with the results, deploy your ENN. These are the steps you need to remember whenever you are developing an ENN. This is important now from your exam point of view. So as you can see, this is the percentage, how much, for example, if there are 100 samples, how much samples you need to use for training data. 60 samples should be used for training data, 20 samples should be used for validation data, remaining 20 should be used for testing data. So there is one more method called as k-fold cross validation. What is k-fold cross validation? That means your training data can be divided into many pieces. So then you are going to test your sample. As you can see, your training data will be divided into k equals pieces, and each training set will be tested k times. So for example, if the training data is divided into 10 pieces, then each piece you are going to test with 10 times. So you are doing this just to obtain better accuracy, just to obtain close to 90 to 100% accuracy. So these are the things you need to remember when you're developing an ENN. So the last topic in artificial neural networks is advantages and disadvantages of artificial neural networks. So we had seen some disadvantages with respect to regression. Those disadvantages have become advantage here. That is what happens with respect to machine learning algorithms. Each machine learning algorithm will have its own set of advantage and disadvantage. So based upon the application you are going to use, you need to decide which machine algorithm suits the best for that particular application. So some of the advantages with respect to ANNR, first one, it can deal with nonlinear data. So when we saw with regression, it was not actually performing well with nonlinear data. The curve we were getting, it was a not a linear curve. So when you are not getting linear curve, you cannot find the relationship between dependent and independent variable. That is what I explained in regression chapter. So, but that won't be a problem when it comes to ANN because it is not using any statistics here. And also, your neural networks will learn from experience. So, you need not program anything. So, once you keep training with many samples, once you keep changing the weightage based on feedback, it will become better. It can handle many different types of problems, classification, clustering, association. And also, even if the data is, if there are some issues with data quality, so the data you are getting as input, if there are some issues with the data, then also your ANN will work good. And your ANN will work faster than compared to other applications, because the main problem with respect to machine learning algorithms is that you need to get results in a quick time. Because if you design a automatic car driving, then all the decisions that needs to be taken has to happen instantly. So that's why your NN work faster than compared to other techniques. So when it comes to the statistical counterparts, which are such as regression, this will provide better results. So these are some of the advantages with respect to regression. So let's see some of the disadvantage. The first one, it is a black box. You don't know what is exactly happening inside that neural networks. You are giving the input and only getting the output. So that's why it lacks explainability. And also, it is still a growing machine learning algorithm, because there are some many different ANN which is getting developed as day passes by. So you might have heard of many different types of neural networks. So as days passes by, as you are getting more information, your ANN becomes better. So it is still an art, it is in experimentation stage. So it can handle large number of variables. So you can give plenty of variables, but that was not the case with respect to regression. If you're giving plenty variables, then the equation would be higher order polynomial. In decision trees also, the decision tree might be very big. So that is difficult to analyze, but that won't be the problem with artificial neural networks. So it can handle with many number of variables. So sorry, it is difficult to handle larger number of variables. So this is a disadvantage actually. So as the number of variables keeps on increasing here, so as you can see in this particular diagram, as number of variable keeps on increasing, there will be plenty of processing that needs to happen. So that is quite a expensive task. So it cannot handle with larger number of variables. So that is the disadvantage. So next disadvantage is it leads, so in order to obtain a better accuracy, it leads larger data set to train your ANN. Your ANN cannot become accurate with few training samples. There needs to be plenty of training samples for the ANN to become very much accurate enough. So these are all the things you need to remember with respect to ANN. So what all we learned? We learned what is ANN. We learned the business applications. There are many business applications. Then we learned the architecture of ANN. Then we learned how to develop an ANN. Lastly, we learned with respect to advantages and disadvantages of artificial neural networks. So just watch the entire presentation. So before watching this one, you need to watch the previous two presentations, which is on decision trees and regression. So complete all the three presentations. So in our next presentation, we can start with clustering. So that is very much interesting. So it can be applied to many real-time applications, or I can say many real-world applications. So that will be an interesting topic. And lastly, association, that is also applied to many real-world application, especially in e-commerce as well as in supermarkets. So that we are going to see in our next presentations. So if you get any doubts with respect to this presentation, you can ping me the doubts. Thank you.